Hello, sir.
Hello, good morning, Kaushiki. Yes.
So, after all, it's a grooming class. So, what will we do here basically again?
So here,
In fact, it's the first grooming class with this subject, that is computer networking.
okay, this is your first grooming class with computer networks. So this is a preparation for your Microsoft placement and all other related placement. So therefore, that type of conceptual understanding and then related questions, okay, that can be asked for this particular campus drive. So that is our objective. So today I will start with some conceptual discussions for from network layer. Then in the next class, I will give you some more. So I will discuss some type of questions from there. Okay. So the syllabus for that particular placement is, I think, it has been discussed from. So just first to see from which batches there are participants. I see some from. I have informed that some are from EC background as well. How many students are there from EC department here? Just okay, okay, 4, 5. Okay, okay. So for them, how many networking class have been done? Like from for the EC students, have you done? So can anyone just unmute and speak such that we?
Hello, sir. Am I audible?
Yes, yes.
Sir, we had computer networking this semester only, and for grooming, we had one class last week. No, last week, actually, this week only, we had an offline grooming class for the computer networking.
And in that offline grooming class, what have been discussed?
Just the basics. Actually, three of us were present, so only just basics were discussed.
Only the basics about the OSI model, TCP/IP model, how
Yes,
that
sir.
communications,
Yes, sir.
that overall communication take place. For
Yes, sir.
example, for networking, the complete communications module is distributed in different layers. Okay, so that particular subject
Yeah, the differences.
started
The
from there.
differences
For
between the two
the
models.
EC, hello, yes.
Yes, the differences between the two different models, the OSI model and the TCP/IP model. That part you were discussing, right?
Okay, OSI model
Yeah.
and TCP/IP model that have discussed. So
Yes.
maybe for others, so just to make some idea, get some idea about others, because here I take the class for BCS 3C students. There are some students here I see, but for BCS A and B, so I think you have already learned. Several the details about several layers, particularly till network layers. Okay, so let's say the associated questions for these other protocols which are there, for example, DHCP, ARP, these will work. But to see what is the very basic objective of all these layered architectures. Okay, so that basic idea, I think, for all students need to very much known. But then some very particular idea. So is there any type of selections of the questions? So have you get any ideas, like for the EC students, they will offer some different questions, CSE students different questions, or I think the questions standard will be
Sir,
same. Yes, Kaushiki. Yes.
sir, I want to ask because um, as I gave lab exam day before yesterday, and there were coding questions. So from networking, also, are there chances of getting coding questions?
I don't think they will ask directly the coding questions, but the questions, conceptual questions, or the methodical questions, or maybe some mathematical problems out of
Sir,
all these,
I would
all these,
I
all
would
these.
like to
sir,
interrupt here, sir. Just a
Yes,
moment, Koshiki.
yes,
The
yes,
last communication which we have with our senior, the alumni, who is working in Microsoft right now. Okay,
yes.
so that lady told us that computer networking definitely is a part of, to be known for support engineering. But then they if you want to choose a subject, like they will ask you which subject you are good at. So if you choose a subject, like somebody chooses coding or data structure, they ask questions related to that. So if I
Yes.
guess if somebody is good with coding and they choose coding, so they will ask questions related to coding, because the girl said that they expect that the students who will be coming for the interview for the specific role has no idea what the role is or what it is all about. So they just do a normal basic interview. Technical now, depending upon which what you are comfortable with. So that what
Exactly.
she said.
Exactly, exactly. So, so sometimes they will ask like in which area you are comfortable, and then they will ask the questions from there. Okay. So as there are
sir,
scope,
I didn't get
so
which
Neha,
which area you are comfortable, and then
so as Neha,
Yes, like if you are comfortable in C, then you can say them that I am very confident that I can, that if you ask me any questions, I'll be most probably be able to answer most of it. So you say that, and they'll ask you questions related to C, because the people who will be in the jury, they will be from different backgrounds. Doesn't have to be from an EC or CSC that they will be asking questions. So if you are comfortable with data structure, tell them that you are comfortable with data structure, that I'm more good at it. So I think I'll be able to answer most of it. So accordingly, if you're good at cloud computing, you say them that you're good at cloud computing, you have better knowledge on it. So they'll ask you questions related to that. And this is
okay,
irrespective of
Sneha.
whichever
Okay,
company
okay,
you will
okay.
be.
okay, Kaushiki, I hope you understand what Sneha want to explain us. So thank you, Sneha, for your input. Normally, in that interview panel, they will ask the questions like this.
But sir,
Yes,
I was actually asking about the coding questions, nothing else other than that.
no, no. For the coding, as uh, the coding questions particularly asked from the programming language type of things. For example, data structures. You will expect more coding questions from there rather than networking. In networking, they will not ask you to code for error controlling. Okay, so they will ask you from the network, particularly from the network, they will rather interested like what are the techniques we used for addressing these issues. Okay, for example, if say the networking is your choice, then they will ask that basic questions and some moderate questions and sometimes some advanced questions. So therefore, for network, particularly students, there are several terminologies what you we need to know, and we are actually discussing these terminologies and the procedures. For example, I can start with revisions of the different protocols what we normally use.
Okay, so now I get it. So networking doesn't have any coding, right,
Yeah,
sir?
yeah. So they
And
will
as
not
per
ask
my
direct.
personal understanding, networking might be the safer option rather than DSA.
Not always, Kaushiki, because networking is very vast. So Kaushik and others. So if you, so you always say the subject where you have more confidence. You know, at least till some moderate level. For example, if someone choose data structures, they should know very well that how that dynamic programming works, how what is the difference between that linked list and the array, how that circular linked list works, what is the difference between the singular linked list and circular linked list, etc. So like that you need that competency for this coding as well. So for any conceptual understanding and also coding, for that you need to actually practice. Okay, I think you need to practice and these things for all engineering students who are actually competing for this type of exam. They have to prepare and they have to be ready with this. Okay, so therefore when you are say that networking is my option, then you need to know from the basics to little bit advanced level. So today, as that discussion started, and also maybe from all other batches for CSC department, you have already done that. Today, let me start with these protocols. What used in different layers. I think that makes sense. Then you will able to actually go with some detailed discussions about these protocols. Then I will go for the network layers, and in the next class I will give you, or I will try to give you some type of questions related to this subject. Okay, so just let me start with very basics about this, because maybe you have studied for different batches also. So any input from the CSE other batches from A and B, how you have studied that subject, and how you have started the subjects. Hello, any inputs from CSE BCS 3A and 3B batch? Hello, hello, anyone who are from BCS 3A? Hello, no one?
Yes, sir. Yes, sir.
Rajrupa, you are from BCS 3A. So now
Yes.
let's say when we start the subject computer networks. So now the very first questions may be asked, what is the difference between telecommunications and data communications? Because here we are starting these subjects also for the CC students. That is the questions. Maybe in interview they can start these questions asking. Can anyone able to answer it? What is the difference between telecommunications and data communications? Rajrupa, any idea? Any students?
No, sir. Right now, I can recall some.
Yes.
Sir,
Yes.
in my case also I could.
And
Telecommunication is any communication that is done via cables. Like the data or the information is getting transmitted from one device to another through cables. Is that right?
so this is used only cable for communicating this data.
Yes,
Are you saying
yes,
this? For data communications also we can use cables, isn't it? I can
yes.
I can
But
I,
then it's a
in the
different
LAN
telephony.
setup I have cables. That cables are connected with different points, and
Different
then
devices.
yes, different devices or different points, and then it's actually facilitate the data communications. Yes, so the name tele is actually stands for far. Yes, Orijit. Yes, Orijit.
Sir, in daily communication, we transfer signals that
Mm-hmm.
may be any form. But in computer networking, we transfer packets.
In computer networking, we transfer packets. Very good. and in the telecommunications we transfer signals. Okay, so that means the signal transmission is take place in so as per Origis he is saying that the signal transmission in take place in case of telecommunications, packet transmission is take place in case of data communications. To some extent this is correct, Orijit, but if you see the physical layer of data communications, then also that particular packet is transformed into electromagnetic signal only, then it is transmitting. Okay, so though this is a packet transmission, but that packet is actually transferred in the form of electromagnetic signal at the very lower layer. Okay, so
Okay.
yes, so I think the, in the both case there are signal transmission, but there is little bit different for this. So just let me just give you some idea about this. Maybe for BCS 3C student they have some this prior discussions, but I think you maybe it is very relevant for you also to recap it. What is there? The telecommunications and data communications. So students, is this slide is visible to all of you?
Yes, sir, we can see it.
Yes. So when I say telecommunications, that is mean communications at a distance. That is, tele is a Greek word that means far or distance. So there we have different type of telecommunications infrastructures. We call telephony, that means voice communications at a distance. Telegraphy, that means a text communications at a distance, and television, that is a video communications at a distance. So that means, as Orijit say, that is a signal transmission, uh, typically the signal transmission only, and there the signals can be form of different type of data, that can be voice, that can be text, that can be video. Okay, and the technology will actually allow us to facilitate the signal transmission at a distance. And when I coming to the data communications part, so that is like Orijit, the very basic difference with the telecommunications and data communications is that in telecommunications we are not considering the exchange of signal. Okay, particularly yeah, there are exchange of signals from the two part, but unlike the data communications, when I consider the television or signals that is coming from the transmitter for the television infrastructures, and they provide us this data to our systems. But when I consider data communications, that is exchange of data between two devices via some form of transmission medium, such as wire cable or wireless. So that means for both case, for telecommunications also, it is not necessarily I have to connect it to the wire. I have satellite TV. I have that all these receiver I can install, and then that can take place. So that is not like we have some packet switching stuffs. So we are not transmitting some packets through the telecommunication infrastructures. So the data communications device are the part of the communication system consist with combinations of hardware and software. That is very important. Like here, when I consider the data communications, I have some physical infrastructures and some softwares or programs we call protocols. Okay, there are several protocols which will facilitate the entire data communications infrastructures. Nowadays, for telecommunications also, we have some softwares we used. So when I consider the set-top box, for in the set-top box there are some software also or patches that can be also updated. You see, so nowadays the telecommunications also consist with some software stuffs, but that is not, unlike the data communications where the objective is to facilitate the packet switching network. Packet switching network means like the data or informations what I want to exchange, I split it or I combine it in the form of packets, and then I facilitate the transmissions. Okay, So in one summarized slide or in one summarized context, that could be your point. What is the basic difference between the telecommunications and data communications? Okay, so now for the data communications systems, what are the components? Okay, so that is the starting point. Rajrupa is, I think, you or other students, EC students also. That should be your point. Like, what are the components of data communication system through which it's actually formed? So we can just brief it using 5 different components. What I used. One is the message, which will actually that information what I want to communicate or the data. One part always there is a sender and another part is the receiver. Sender is actually sending the data or message, and receiver is one party who are actually for actually receiving this message. And there is a transmission medium which will transmit this message. And lastly, there is some rule or software programs which will actually facilitate the overall data communications. So therefore, there are 5 different components: message, sender, receiver, medium, and protocol. Any questions so far from any students? Is it understood what are the components which will form the data communication system? Okay. Everyone understood Orijit? Is it understood? Is he students?
Yes, sir.
Hello?
Yes, sir.
Okay. Fine. And I think that is known also for the EC students, the type of connections or the type of data flow, simplex, half duplex, full duplex model. If it is known, if it is not known, you can just say. So I just quickly say what is this. When I consider simplex, that means data communications in one directions. Okay, so this is unidirectional data flow. For example, when I consider the connections between the mainframe machine, IBM mainframe. Maybe you have heard about this IBM mainframe in 1960s. They have made it with a client. So in that case, they are actually giving the informations to the client from the mainframe server, and that is a typical example of simplex data flow. Okay, the data flow are happening only unidirectional. So therefore, the question is that if client need the informations, they they're not allowed to use the same cable. They have some different cabling, like from client to server one cable, and then from server to client different cables. So that was the infrastructures in 1960s. So that was an example of simplex data communications. When I come to the half duplex data communications. So that half duplex means on the directions but one at a time. So that means when this left side stations is sending data, then the right side stations are not sending, or one only send data at a time. So that is the half duplex. So that means the bidirectional data flow is allowed, but one at a time. That is half duplex. So in some protocols, it used when one actually used that network infrastructures to send it. So sometimes for some voice telephony network. So that is also part of data communication. So when I consider the VoIP call, in the VoIP call, suppose two persons are speaking with each other. Now, if two persons are talking together, it will not audible to both of them. So now when I consider the voice call, then if uh, one party is speaking, then others are not speaking. So therefore, the directions of data are flowing in that directions only. Then, after completions of the speaker, the next party can speak. So now, when I consider the VoIP call over internet, I am using actually half duplex type of data communications. So that means both way communications are actually feasible, but one at a time. But when I am considering the some chat messages or the others, so then that particular uh, things may be violated. But particularly for the audio signal transmissions over the internet, I can say that is an example of half duplex data flow. Okay, now in full duplex data flow, so that means in real time bidirectional data flow. That is a typical example of full duplex data flow model. Okay, so I think I am so now in the interview. So what do you know about computer networks? What it is? Very basic questions can be asked. So the computer networks is the collections of two or more computers that are interconnected with each other to perform data communication using the data communication protocol through communications media. So that means by using the networking components, computer networks actually uh, we see that computer network infrastructures. Okay, that is some interconnections between two or more computers. So that means sometimes these type of questions asked. Suppose I just connect two isolated computers. Is it a computer networks? So the answer is yes. It can be a computer networks, but that perform data communications using the that should perform the data communications using the data communication protocol for this communications media. It could be wireless, wired or wireless. Okay, so therefore, so not only the connections, now not only the connections between two wires, but also the these components need to play the role. Otherwise, it is we cannot say this is a computer network. For example, I have a LAN setup and I am using FTP protocol. So therefore, I am using this protocol to facilitate the connections between two computers. So then I can say this is a small computer network like this. Okay, fine. So there are some things very basics, but we not focus on this. So that is some network performance measures where I have some network elements what we used. So you know these are the devices we use to frame our networks. We have switch, we have routers, we have the communication channel. So just very basic questions. What is the task of a repeater? And can anyone know what is the task of a repeater? Repeater is the point in the LAN where through this point the signals are actually transmitting to one machine to another machines. So these are some junctions of the wire in LAN setup.
Sir, aren't repeaters used to regenerate the signal when they become too weak?
The repeaters are used to regenerate the signals. Yes, so regenerate the signal means like during transmission, the signals actually attenuated because of so they are actually losing the energy. Then the repeaters are actually amplify the signal strength and it will pass to the other end of this wire and other end of these networks. So
Sir, do they amplify the signal or regenerate it at the same strength?
So that is the same thing now. When I consider the regenerate the same strength, that is they are actually boosting the energy of the signals which are actually losing by transmission through the transmission medium. It can be wired or wireless. but particularly repeaters are used for LAN setup. Okay, so therefore for all these networks device, having that infrastructures to regenerate, as you say, or amplify the signals, where actually it will get its original shape. Okay, so then can anyone tell me what is the difference between the transit time and response time, in your opinion?
The
Yeah.
time which it takes for the data to move from one to the what should I say, the data packets to move from one device to the another,
Yes.
like the one which who is sending, who's transmitting it, the time which it takes for for it to cover the distance and get received by the second device, and the response time is just similarly, just in the reverse way. The response time is how long it's taking for the um, the data packet to come back, or the answer to come back from the second device to the first device, from to the transmitter, from the
Yes.
transmitted device.
Yes. So more or less, you are answering correctly. So transit time is the time taken for the packet to travel from the sender to the receiver, and the response time is the time for the acknowledgement from the receiver to the sender. Okay. So now in that context, I can ask the questions. What do you know about piggybacking? What do you know about piggybacking? Can anyone able to answer? That is the questions related to this transit time and response time.
Sir,
Yes.
I want some definition of this piggybacking because although I had attended your classes, I somewhat did not understand it properly. So, can you?
Yeah.
Sir,
So,
may I
so
answer?
yeah, sure.
So it's just using like free Wi-Fi without any like. I don't want to harm any other person's computer or connection, but I just want to use the Wi-Fi for free.
You want to just not want to harm others connections, but
Yeah,
you want
use
to.
it for free, just for my purpose.
Yes, it is. You can use the connections for free. Yeah, so like in that particular context we can explain the complete scenarios. So I start with the EC students, you just respond me, then for the CSC students I can just see what are the scenarios. You have learned the data link layer, na? Data link layer task. EC students, you answer me, you learn how the data link layer actually works, more
Link
or
layer
less.
is the, yes, it comes after the physical layer.
So, for example, you have heard about this stop and wait ARQ protocol. You have studied this stop and wait ARQ, automatic repeat request. Have you studied this protocol? Stop.
I am not really, I don't remember actually.
Anyone from BCS 3A or 3B batch? Have you studied this stop and wait ARQ protocol? Rajrupa or anyone? Hello?
Well, sir,
No, I'm just asking BCS 3A or 3B students, then I will answer you. Rajrupa, is it discussed in your class? Stop and wait ARQ, because I am discussing one concept at a time. That will actually helpful for this, because you are the interviewer. They have their knowledge set, and from there, which type of questions they will ask, that is not known to us. Okay. Now the point is that which type of questions they will ask, we have to be prepared. Like if I say I am good in this subject, I have to prepare with at least some basics. So that stop and wait ARQ protocol is used in data link layer, where we are actually considering the data flow control mechanisms. We are considering, that is addressing the data flow control mechanism. In stop and wait ARQ protocol, what is happening? The sender is sending the data packets to the receiver, and receiver is giving the response accordingly. Like one frame is sent from the sender to the receiver, then after receiving the frame, the receiver is sending the acknowledgement frame to the sender. So that is the stop and wait ARQ protocol. So the details of the protocol I am not coming, so that you can see in that scenarios, when for each packet which is sending by the sender to the receiver, and the receiver need to just send the acknowledgement separately, it will give more overload to the network, and it will also take more time. Therefore, that frame which is sent from the receiver to the sender, the acknowledgement frame actually appended with the original frame which is sended from the receiver to the sender. So that is like a train. You see the mail bogie of the train is actually appended at the end of the main train. So that mail bogie, you see the mail bogie means the all the letters and others which are actually maybe some train is coming from New Delhi to Kolkata. Now the mail bogie is actually appended at the end of this particular train for sending these letters to for the Kolkata, for example. So piggybacking is the same thing. The acknowledgement frame not sent isolatedly, but it is actually appended to the original frame of the receiver. Okay, Sneha, is it understood little bit what is piggybacking and how this is actually related
Yes, yes.
to our discussions about the response time and transit time? Because that is the topic of that response time and transit time, and that is the applications of that. Yes, Kaushiki, you have some questions. Now you tell me.
Sir, as when I asked about piggybacking, then Ankan said that it's about free networking access without harming someone else's network
Exactly.
access.
This is the free
So,
networking access means like when I am using this piggybacking concept, I am trying to sending that acknowledgement frame, but I am using it free because I am using it with the original frame what I want to send to the sender, because here we are considering bidirectional data flow. Ankon, now you understand why this is free? Ankon, is it with
Yes,
you?
sir. Yes, sir.
Because I am free, I am using it free because I am using the same same time and also same infrastructures. So therefore, this is free for me. If I have to
Yeah.
send the
Yeah.
acknowledgement separately, then I need some time, and I also need some network bandwidth
no, sir,
to
sir.
transmit the acknowledgement frame. Yes, Koshiki.
Sir, when you are speaking about this acknowledge frame, whom we are sending the acknowledgement frame in piggybacking?
The receiver, like receiver sending this acknowledgement frame in piggybacking, where this is sending the acknowledgement frame with the original frame what he intended to send to the sender, because so there we are considering full duplex data flow. Now if I do the piggybacking, now this is both from the sender, because you see here sender and the receiver are playing the dual role, because when sender is sending the packets, I am saying this is sender. When sender is receiving the packet, I am calling the sender receiver, isn't it? Because they are the two party are playing the dual role. Sometimes sender become the receiver, sometimes receiver become the sender also, isn't it? Kaushik, is it understood?
Yes, sir, just like we do in emails, right?
Yes, in emails you can think about this. Yes, yes, or in the chat message, like I can be receiver and I can be sender. When I am receiving the chat message, I am the receiver. When I am sending the chat message, I am the sender.
So
Okay.
that's what is piggybacking. Yes, sir, okay.
Yes, no, that's not piggybacking. Piggybacking is the way when I am appending the acknowledgement frame with the original frame. What is sending to the sender. That is piggybacking.
Okay, so okay.
After getting the acknowledgement, it will get that information, or it makes sure that original frame is transmitted to the receiver. Okay. So these are the
Okay,
things,
so
and
okay,
I
okay.
think all of you know what is delay and what is the throughput. So can anyone tell me about what is the difference between the throughput and bandwidth of the network? So
Can
this,
you repeat again?
what is the difference between throughput and bandwidth? Throughput and bandwidth. So you know that what is throughput? All of you know what is throughput. Delay, I think you know. uh, the, the delay factors to transmit a particular packet to one point to another points, like the time taken to transmit it from one point to another. Not only the transit time and response time, but also the delay due to the congestions in the network. So that means the delay can be added with the transit time and response time due to the congestions of the network. The throughput is the,
Amount of data that passes,
yes,
like
amount the
using
amount of information which is passes from one node to another node. Correct. Now bandwidth,
and bandwidth is the maximum amount that can pass.
yes, the bandwidth is the maximum amount of informations, or the maximum amount of data that can pass. So that means if I say the throughput is 50%, that means I am using the 50% of the capacity of this network. When I say the throughput of this network is 50%, that means I am using the 50% of the capacity at maximum to for this network. Okay. And what is jitter? I think everyone know this. At least EC students must know it. What is this jitter? That is the lack of synchronizations in the network. Okay, for example, that sender, what is sended from the sender, the receiver should get it in real time. Therefore, there should not be some synchronizations problem between the packets, or there should not be some synchronizations problem between inside the signal. That is jitter. I can give you the example of this synchronizations problem. I say hello, then the receiver also say need to hear this message hello, but sometimes due to jitter it say hello like this. Everyone understood what is jitter? This is because of the lack of synchronizations of the packets. Orijit, Sneha, or other students.
Yes, 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 yes.
Yes, so this is jitter. So these are very basic concepts actually, but sometimes we forgot. So during the interview, we forgot this. They can ask you this type of simple questions also, along with others. Okay, so reliability, security issues. Okay, so that you also know. I'm not going into the details. So today's my objective is to discuss about the protocols first. Then I go to this concept. So I'm not discussing about this topology. Topology is known, I think, to all of you. So if it is not, that you just see some basics. I'm not discussing the protocols today. So the circuit switching, packet switching. Maybe I can just discuss quickly this one. So in case of circuit switching, you actually need some dedicated circuit, and we are switching the circuits. We are switching the circuits to facilitate these communications. I think in case of conventional telephonic communications, when I consider the conventional telephonic communications, we are using circuit switching network. Okay, so therefore, suppose here one particular point or telephonic port is connected with a particular telephonic port in the other end, that is actually established that circuit between these two particular node of this telephonic network. Now if I want to change the connections to other telephonic point, I need to switch the circuit. That particular circuit which is established between these two telephonic point, I need to switch the circuit. Okay, so therefore there are some telephone exchange, the concept of telephone exchange. You see, students knows this very well. Telephone exchange, and they are actually establishing these connections with these telephones. So now the mobile technologies are actually getting very popular. But when you consider the conventional telephonic exchange, when we have some office or some point there, they need to actually change the switch to make the feasibility of the connections to two different parties. So they have, for example, they have dedicated 8 line connections. For example, when someone calling from Kolkata to New Delhi, then that at maximum 8 persons can call from Kolkata to New Delhi. That was the infrastructure. If I'm calling I'm just recalling the situations in end of 80s. Maybe you have not born in that time. So in the end of 80s or the beginning of 90s, that was the infrastructures. Okay, when my grandfather want to call to someone to Delhi or Mumbai, they need to first contact with the telephone exchange, then they will give the connections to the other cities, like that. That was the infrastructure. That was actually circuit switching. They need to actually switch the circuits when they want to make these connections feasible. Now when I consider the data communication, the packet switching take place, where I have the packets, they are using the same infrastructures, and then you have the queue of the packets which are actually moving bidirectionally, and that will use some rule or protocols to facilitate the entire communications. Therefore, the
Sir,
packet. Yes, Kaushiki.
in the packet switching, after that, the exchange of data between that line is not visible because that box of.
Okay. Now it is visible. In case of data
Yes,
communication,
sir.
the exchange of data between any two users happens in the form of small data packets that allow the system to store and forward the packets following by some rules or protocols. Actually, the router in a packet switch network maintain a queue that can store and forward the packets. Okay, this is more efficient than the circuit switch network. However, sometimes the packet may encounter some delay due to the congestions. Okay, fine. Okay, so then there are revolutions of the internet. I'm also not going into these. Only that things maybe need to know by all students. What is the structures of today's internet? So I have some main backbone, which is actually large network owned by the communication companies. For example, Sprint, Verizon, AT&T, NTT, etc. These are actually hosting the backbone with some satellites. They are using some satellites to hosting the backbones by this company. They are actually sending the satellites to make that internet infrastructure feasible. So that is the backbone. And peering point are some complex and robust switching systems connect to the backbone and with the provider networks. So provider networks are the giants. So they are actually hosting the entire internet infrastructure. So that is also hosted by this company who are hosting the backbones like Sprint, Verizon, AT&T. We called sometimes we call ISPs or internet service providers. Okay, these terms is I think known, or you can just have a quick look on that. Then the customer networks will come place, which are actually the customer for these internet infrastructures. Okay, for example, the big customers are Google, Yahoo. They are big customers from the provider networks. Okay? So that is the, in nutshell, that is the structures of today's internet. We can see that is. So now you can just recall how these are actually working. Okay, so just a question for the students, like for hosting the backbones and the peering points, why they are using geostationary satellite? Can anyone tell me why the companies are using geostationary satellite for internet communications? The geostationary satellites are mostly used. Why? Any reason for that?
so that they do not have to track the satellite motion.
We- Hello, just a moment. Someone is calling. Yeah, continue.
The ground antennas are aimed in such a way that the satellite they do not have to track the location or the so they do not have to track where the satellite is. So geo satellites are used for that.
Yes, yes. Geostationary satellites are used because of that reason. Like they will have the relative positions of all the nodes will remain unchanged. The relative positions of the nodes will remain unchanged. For example, the relative positions of the peering points and the provider networks will remain unchanged due to establishment of the geostationary satellites. So that is one of the main reason for using or preferring geostationary satellites for hosting these internet infrastructures. Okay. So these are the different organizations who are hosting these ISPs. So I'm not also not going into these details. Uh, Protocols, the basic definitions of protocols. So this is some set of rules. Sometimes this is very popular questions in interview. They ask, what is protocols? Okay, what are the key elements of the protocols, etc. So that is some set of rules or some software module which will facilitate the entire data communications infrastructures. Okay, so for when we are just learning different protocols, um, uh, the starting point is that protocol layering. Why we are actually layering or the protocols in different layers. So the objective is that, like, there are several tasks actually. There are several tasks what I want to distribute among different layers. Therefore, I am just considering this protocol layerings. And when I consider a single layer protocols, so then there are only a single layers. I don't need multiple layers actually. When I have some task, just I identify some task when I don't need to split it in different layers. Okay, so then I can consider sorry, this is a single layer protocols. Okay, so for example, sender is talking and receiver is listening. Okay, so then we don't need multiple layers. That is a typical example of single layer protocols. And when I have multiple layers, then I have multi-layer tasks. Therefore, I need multi-layer protocols. So in this case, when I using this physical layer, data link layer, network layer, transport layer, and application layers, etc., these are actually an example of multi-layered protocol hierarchies. When I need to split these into multiple layers, therefore this is multi-layer protocols. For example, here I see I have the higher layers, the middle layers, and the lower layers. Okay, so this is an example, typical example when someone is sending a letter to others. So I just quickly read for you. Then you understand what is there and what is the objective of doing or learning these different layers here. For example, someone sender is write the letters, then put inside the envelope, then she dropped into the mailbox. That is the task of the first layer. The second layer, the middle layer, which is carried from the mailbox to the post office, and the lowest layer, the letter is delivered by the post van from the post office to the other destinations. So then there is some carrier. This is the channel. Then the other hand, the receiver is received the letter. That the letter is delivered from the carrier to the post office. Then the other complementary things is going on in the receiver end. Okay, so therefore this is a typical example of this multi-layer tasking or multi-layer protocolling, which is exactly doing in this network. In this network, we are actually doing that. So there are two principles of protocol layering in that context. One is that the first principle is this will perform two opposite or complementary tasks, and second principles they are containing identical object. For example, when I consider packets in network layer, both side of the sender and the receiver, they are they are using the term packets. When I considering frame in data link layer, both from the sender side and from the receiver side, they are actually considering this frame, the content as frame. Then when in the physical layer of both sender and the receiver, they are using bits as the unit of transmissions like this. So I am not going into these details that have been discussed previously and all students know. I am just going into so this is questions actually. Uh, so can anyone able to answer it? Suppose a message is delivered from source. So just look this figure carefully. Suppose a message is delivered from source A to F and from A to E. Okay, how many times it passes through the data link layer in case of A and 2, 1 and 2? Hello. Suppose firstly I want to transfer it from A to F. Please just look this carefully. I have the end station, then I have intermediate system or routing point or routers. From there I am just delivering this. By the way, when I considering the data link layer, this is actually facilitate the hop to hop delivery, and when I consider the network layer, it is facilitate the source to destination delivery. That is the delivery from the source to the destinations. Suppose I have these routers and the routing points infrastructures like this, and then I have used this. Then the network layer, this is a typical example of source to destination delivery. Can anyone able to try for this problem?
So I'm already thinking.
Okay.
So for case
So for
two,
first one it is
the
3 and
number of
for second one it is 2.
For one, what is the answer from A to F?
Sir, it is 3. Means 3 times.
The A2F is
no,
2, I think, and A2 is
no,
1.
no, no. It for case one it's 2.
Just
For
look.
case three it's 6.
Yes.
Case one it's for 2. Sorry, for case one it's 2. Yes, and case two it's 6.
Sir, but aren't B and E both routers?
So that is very interesting questions. Actually, that questions was asked once in some gate questions, I think. Let's say when I consider passing that packets from a point, from we are considering the passing from the top layer to the lower layer. Now I consider the last three layers here. Now I am just asking the questions in the context of data link layer for these questions. Now you just look this figure carefully. Like here, when I am passing the when that packet is passing from point A, it is passing data link layer one time. Now, when it is coming to the next point, intermediate point, which is B actually, this is a router, this is a router, then this is passing through the data link layer two times. In each router, they are passing through the data link layer two times. But this is passing through the network layer only one time. Therefore, when it is passing a router, it is passing data link layer two times. So therefore, how many times it's passing from A to A?
Three,
One time, two time,
two, three.
three time, four time, five time, then six time. Therefore, for the A, the question A, the answer is
Yes,
six. Six.
yes.
Okay. Now the same questions can be asked. How many time it passes through network layer, which is a source to destination delivery actually. The answer will be four. One, two, three, four. It is passing through the network layer four times for this particular figure. We have to always keep in mind when this is passing through a particular router, it is passing through the network layer one time, it is passing through the data link layer two times. It is coming into the network layer from the data link layer and it is coming to the other point through the data link layer. So therefore, they passes data link layer two times. Okay. Now the second questions from A to E. I think from A to E, data link layer how many times? One,
So what is the answer of the first?
first six. Six.
Okay.
For the second, the answer is this is one, two, three, four. Because it's already arrived to E here, then we need to don't need to consider the passing out of the signals. Okay, therefore we have to or passing out of the packets. We have to consider only to coming in the packet. So therefore, the for question two, the answer is one, two, three, four. Four times it passes through the data link layer, and it is passes through the network layer three times. One times, two times, three times. Anyway, when it is coming to the E, it is passing through the network layer one time. Okay. So when I consider data link layer, it is an example of hop to hop delivery. When I consider network layer, that is source to destination delivery. Hop to hop means point to point delivery. Like here, data link layer is not considering the delivery of the packets to other routers, but it is only considering the flow of the packets from one hop to another, the next hop. The network layer actually thinking about the entire source to destination delivery. So I will show you one example, then how that entire encapsulations and decapsulations of the packets are take place. We'll just discuss quickly. Okay, I am not going into these. I have to skip some more. I think everyone is known now what is physical address, what is IP address, what is port address is known to all of you. Physical address, IP address, port address. What is the
Yes,
difference between the physical address, logical address, MAC address, etc.? In that context, when I consider the transport layer, they are using some port number. Okay, the port number for the data streams what are actually transmitting from one point to another point. There are multiple streams actually transferring from one point to another point. So there we are using some logical connections, or we are establishing some logical connections between the sender and the receiver or transport layer. Okay, So which is the protocols in TCP/IP which are actually facilitate this? Can anyone tell me for transport layer? Which protocols is used?
TCP and UDP.
TCP and UDP. Okay, so TCP is the protocols is actually establishing these logical connections between the sender and the receiver. Okay, and here this is the port number which is facilitated the process to process communications between the sender and the receiver. Okay, so there, this is the total summary of the OSI layers which I have already discussed. I will not repeat it. Just to make sure what is the difference between the TCP/IP and OSI model in this diagram, where that presentation layer, session layers, and applications layer are combined to the application layer for TCP/IP protocol suite. Now I am coming to so this is actually I just want to say that different protocols which are used in different layers. So this is very important diagram where I see different protocols in application layers. I have the protocols SMTP, FTP, HTTP, DNS, SNMP, Telnet, etc. In transport layer, TCP is the main protocols, and also for user datagram we use UDP or user datagram protocol, SCTP, stream control transmission protocol, and in the network layer I have the IP. Then I have different subordinate protocols of IP. So in for your placement, little detailed understanding about all these protocols is required. Okay, ICMP, IGMP, DHCP, RARP, ARP, how these are actually working, what is their detail technical flow. I will say that the details flow of this, because there are some data flow model for all these protocols. So to understand how these are work, you have to just consider two different parties. One is the sender and another is the receiver. Then you have to just check how this type of flow is going on for different protocols. Okay, in data link layer and physical layer for TCP/IP particularly, we are not there is some protocols, but there are different techniques. For example, data link layer for flow control, as I say, the stop and wait ARQ, go back in ARQ, simplest protocols, etc. These are the flow control. Then collision control, or this congestion control protocols, Aloha, slotted Aloha, CSMA CD, CSMA CA, these are used. Okay? Normally, these are the different things that have been already learned through your network course. Okay. BCS 3A, 3B students, is this known to you? This Aloha, slotted Aloha stuffs, is it done? EC students, you know this Aloha, slotted Aloha stuffs? This hello, Mac sublayer of data link layer. You at least say yes or no. Anyone? Hello? Am I audible or too much silence?
So we can hear you.
No, I'm just asking this for other. Sneha, is it taught this? You know this Aloha, slotted Aloha, CSMA CD. This is the congestion control. Rajrupa, is it? Yes. So therefore, these are the things is actually, these protocols are actually used in. So therefore, I think that is known to all students. Then you need to just quickly revise this before your interview. Okay, so there I'm just going into the little discussions about these protocols, and then I think in the next class I go to the little bit more detailing about all of these protocols. So when I consider these IP, which is internet protocols. Okay, this is a network layer protocols, which defines the format of packets. Okay, the format of packets or datagrams, which defines the structures of the addresses. Okay, for example, which is responsible for routing of a packets, okay, from the source to the destinations. IP is a connection-less protocols. Why? The reason is that IP is not actually considering some flow control, no error control, or no congestion control. This is responsible for unicasting and multicasting. Okay, can anyone tell me what is the difference? Just very basic questions. What is the difference between unicasting and multicasting? What is the difference between unicast protocols and multicast protocols?
So unicast is one-to-one transmission. There is only one sender and receiver. And in multicast, there is one or more senders and one or more receivers.
So then, in case of unicasting, when you have two different parties, then it is using a single interface of that particular network. In case of multicasting, they are using multiple interface of the network. For example, in case of multicasting, they want to send a packet. In that multiple interface, the several group members. Okay, you have in the subnet masking, you have the concept of group. Then several group members of the masks, they can receive the same packets. That is the concept of multicasting. Then we that sender use multiple interface to send these packets. So if everyone know what the interface mean. Interface means what I want to say for the interface. No, it is not known. Okay, I think I will quickly show you this. I think I have 10 minutes more. Just I finish these stuffs quickly.
Uh,
Yes,
Interface in a network means it's the interconnection between a computer and a network, be it public
exactly.
or
Very
private.
good, very good. Interface is the interconnections between the computers and also the network infrastructures. That is interface actually. So therefore, not only the computers but also the networks, both will actually form the interface. And for in case of multicasting, we are using multiple interfaces. Yeah. So there, you have some other protocols which are we call some subordinate protocols of that, and some details understanding about these protocols are required, particularly DHCP and ARP. That is also in the syllabus of Microsoft. So that is DHCP and ARP. That is the dynamic host configuration protocols, which helps IP to get the network layer address for the host. Now, your task is to go a little bit more how the DHCP work, how it will get the network layer address for the host. And another is ARP, that is address resolution protocols, that is to find the link layer address of the host or a router when the network layer address is given. That is the task of the ARP or address resolution protocol. So, similarly, ICMP, with the name you will see this is an internet control message protocol, which helps IP to report some problems during routing. IGMP, internet group management protocol, which helps IP to multicasting or multitasking. Okay, so then for transport layer, I have TCP, which is transmission control protocol. And the task of the TCP is to facilitate the flow control, error control, and the congestion control. This is a connection-oriented protocol. TCP is a connection-oriented protocol because it establishes the logical connections between the sender and the receiver before transmission. Okay, UDP is user datagram protocol, which is a connection-less protocol, which will actually sends user datagrams without creating logical connections. I think you have in your lab you have done these sockets. That is, we have learned the TCP sockets and UDP sockets. That is one of the experiment we use to understand that connection oriented and connection less stuff with this experiment. And another is subordinate protocols of for transport layer is SCTP, that is Stream Control Transmission Protocol, which will handle the multimedia applications, because we have different port number in transport layer. Different streams need to be transmitted. SCTP is one protocol which will actually help to manage these streams informations. For application layer protocols, you will have a look on this into details. HTTP DNS, SMTP FTP, Telnet SSH, SNMP, IGMP. I think I can share this slide to Tanujit sir. For other students, you can get this content from him, to him. Okay, for this particular content, what I delivered, then you will have a look on that, and you can have some additional study from there. Okay, I will share this content with Tanujit sir. He will share with you. Okay, is it fine? EC students and A and B students. I think for C students, this content is there. Okay, is it okay? I will just share this content before I discuss the others content. Okay. Okay. So I think today I stop here. Rather, we have another class from 1 p.m. If you have any more questions, more queries, I can just take these questions. The next class I will discuss some more problems. So for the multicasting examples, so what I want to share, what is unicasting and what is multicasting. Yes, that is actually unicasting. I mean, interface means the computer systems along with the network. So this is the network it is using to send these packets from the source S1 to the destination D1. That is a typical example of unicasting. Now, when I consider multicasting, they are using multiple interfaces. Like I have the group members G1, which is masked, and they are actually splitted in different points. Now they are using multiple interfaces. Like here, when source S1 is generating to send a particular packet, it is sending to the next router which is associated with that particular source. Now from that routers, it is actually splitted to two different interfaces. So this is one interface, that is another interface. Please note that in case of multicasting, they are not using multiple packets from the source. They are using only single packets, and when it is actually using different interfaces, they are actually sending to different interfaces like that. So therefore, the replica of these packets is actually made in different points. Here also, I have made two different replicas of the same packet. So that is a typical example of multicasting where it is using multiple interfaces. There is another one we call multiple unicasting. That is not a good idea. Like that here for the multiple unicasting, uh, multiple packets actually initiated from the source, and then this is actually distributed to different destinations point. Now, unlike the group members, here D1 is getting one packet, D2 is getting another packets, D3 is getting another packets, like that. So therefore here each packet is using a single interface. Each packet is actually using a single interface. Therefore, for multiple unicasting, we are actually segregating different single interface together, unlike multicasting. Okay. And what is broadcasting? What is the difference between the multicasting and broadcasting? Can anyone tell me? Unicasting, you know. Multicasting, you know. There is another term also we call broadcasting. What is this? Can anyone know what is broadcasting? For broadcasting, actually, there is no choice. They are not choosing a particular interface like the multicasting. Broadcasting, it is actually sending the packets with all the recipients with its periphery. That is the broadcasting. So therefore it is not choosing a particular interface. So for example, if I just consider the broadcasting for that, it should not actually avoid this node. For broadcasting, it is using all the interfaces in its periphery. So there is no selection of particular interface like multicasting. Okay. Okay, so now this is already 12:56. I have I can wait for another 2 minutes before we have next class from 1. I just stop sharing. If you have any questions, you please ask.
Sir, can you please share the PDF? And second, sir, is there any way that if we have some questions or something which we need to know, so in any way of communicating with you over WhatsApp or anyway, that is possible.
Okay, okay, Sneha. Sure. I think you have my. You can just take my WhatsApp number. All students. This is I can write my number. You can just drop
Or
me.
sir, you can ask Tanujit sir to add you in the Microsoft group. Everybody is in there. So whoever will have whatever questions, they can directly tag you and put you the questions so that you can help us with it.
Okay, okay. I will ask him also. Or also you can just if you have any queries individually, you can just contact me.
Okay, sir.
Maybe individual students may have individual questions, individual problem, individual issues. They can also separately ask me. No point. I think you get my number 9679416681. You can write me if you have any queries, and I will share this PDF with Tanvir sir. We will share this with all of you. Okay. So all the best. You just continue preparations in this spirit uh, with all this content, conceptual understanding, some more that will help you. Okay. Okay, then we are closing today. All the best. Thank you.
Thank you, sir.